All right, so thank you so much for joining us today. We had those results from the poll in, and it looks like it's a pretty even split, actually, who is here already building something in production or in the process of taking something to production, and who's here to learn and tinker. So thank you for answering that question so we know a little bit more about who you are and who we're speaking to. By way of introduction, my name is Bear. I lead the developer relations team over at Pinecone, and I'm joined today by Kyler, who is an engineer on our growth team. And we're excited to talk to you a little bit about the contents of this series that we have started that addresses questions about using vector databases in production. And this came about because we have talked to lots of our customers over many, many months about the kinds of challenges that they're facing as they're bringing their RAG apps live. And even the most sophisticated engineering teams still have questions and things that they're grappling with and things that they come to us to ask questions about. So we wanted to pull together some content to answer the common questions and also give people a chance to learn from one another, share what they're doing and what's working and what's not. So why did we start with multi-tenancy? We started with multi-tenancy because it's something that people ask us about a lot. It's an architecture pattern that pretty much every SaaS company needs to use, and a lot of internal tools that are building for people within a company need to use too. It's a pattern where you have a single instance of a system that is serving multiple customers or tenants at the same time. And each tenant has to be set up to operate independently with data isolation and between tenants. And it's efficient because you can share infrastructure and operational overhead across the tenants, but it does add some complexity because you have to think about things like, how are you guaranteeing data isolation? How do you make sure that different tenants that might have different workloads or have different contractual SLAs with your company still see similar levels of performance? And there's a lot to dive into in the topic of multi-tenancy generally, but luckily, when you're talking about working with Pinecone, Pinecone takes care of a lot of these concerns for you automatically, like enforcing data isolation, managing load, and ensuring fault tolerance for you, all for free by using Pinecone. You just need to know a little bit about how Pinecone works to set it up effectively. So the first thing you need to know about in general is the structure of data you store in Pinecone. There is the vector embedding, of course, that's the meat of things, but every record in Pinecone is made up of an ID for that record, in addition to the dense vector embedding, an optional sparse vector, and an optional metadata blob, which is a set of key value pairs that you can associate with the vector embedding. And for RAG, people often use that metadata blob to store, for example, a reference to the document that the embedding was taken from, or even the plain text of the chunk that the embedding represents. Or it might be information that you might want to use later on to filter a query. So for example, which people or roles within your organization should have access to this information. All of those things are things that we see customers store within that metadata blob. So records are stored generally within indexes. And indexes are the highest level organizational unit of vector data in Pinecone. So when you are storing vectors or you're querying vectors, you query to a specific index, and vector operations generally happen over the contents of an index. We think about indexes and what should live in a separate index in terms of workloads that they serve. So all records in an index are meant to have the same dimensionality and use the same distance metric. So if you're using different embedding models for different workloads, or you have just different forms of vector embedding data that you need for different pieces of your application, those might end up being in different indexes. Within indexes are namespaces, and those are the fundamental unit of separation in serverless. Any record exists in only one namespace, and what's more, any query that is issued to Pinecone within an index, it's only hitting one namespace at a time. Now, if you are working on a relatively small scale and you have not used namespaces before, you might be using the default namespace, which is just named by an empty string. And so in cases where you're running a query to an index and you haven't specified the namespace, it will default to that default empty string namespace. We'll get to that in more detail in a second. But queries are limited to one namespace, and you can specify which one you want to hit so that the requests search different subsets of your index. So this is kind of difficult to talk about in the abstract, so we're going to use the example of a smart wiki application, which is a multi-tenant SaaS app. And in their case, the tenants that make sense are individual customers, because the data isolation that needs to happen between tenants definitely needs to happen between company A and company B. And Smart Wiki wants to guarantee that customer A's behavior is not going to affect customer B. And just to add a little wrinkle so that we can talk about how this might exist over multiple indexes, SmartWiki has different types of workload that they store in different indexes that might have different dimensionality. And tenants within SmartWiki might have namespaces in each of those multiple index. So what does that look like functionally speaking? They have their Pinecone organization, and let's say they have index A for RAG workloads and index B for semantic search workloads. Tenant A, which is customer A, Acme Co., has an index in each of these namespaces, and tenant B has an index in each of these namespaces. Some of their customers might have namespaces in each of those indexes. Tenant B may or may not have a namespace in both indexes. It might just be in one. But what this means is that at query time, for example, we're looking for a RAG query against customer B's data. And so we're going to route it to the RAG workload index and only search over the namespace that belongs to customer B. And so by doing this, we decrease the overall size of the data that Pinecone is going to be searching over, and it can create some efficiency both in the searching process, and also we are guaranteed that isolation where this query is not going to hit anything that belongs to customer A. So upserting to namespace is straightforward. All you need to do is along with your call to upsert, define the name of a namespace. And namespaces are created implicitly when you specify that name for the first time. And if you don't specify a namespace here, it will default to the empty string namespace that I talked about before in the index slide, where it's just the default namespace that you get that could be the entirety of the contents in your index if you haven't separated out into namespaces specifically. Then when at query time, you need to pass in your namespace's name as a string parameter, and you'll get back the results relevant to that namespace. Now, if you don't specify the namespace, it won't look over your whole index. It's going to look over just the default string namespace. So that's a thing to be aware of when you're running queries. Any query that you send to Pinecone hits exactly one namespace. The nice benefit that you get as well when you are modeling that a tenant is one namespace in Pinecone is that offboarding is really simple. All you have to do is call index delete with the name of the namespace, and Pinecone takes care of the rest in terms of deletion. Super straightforward. Now, there are some times where you might need to use a mapping table to resolve where you need to point a given query. So for example, in the SmartWiki case, we might need to know what type of query is coming through and decide which index we want to send it to. And beyond that, which namespace within that index belongs to that customer's type of workload. So you might have something that looks like this. Another time that you might end up using a mapping table is that there are limits to the number of namespaces that you have in a given index. So our serverless limits for the free tier are 100 namespaces, 10,000 on standard, and 50,000 or more if you talk to us within the enterprise tier. So you might need to spread your data across multiple indexes, but you can also contact our support team and talk to them about what's possible given your needs. So what if you actually do want to be able to query across tenants? In that case, namespaces would be a kind of painful implementation choice because, and like I said before, any query only hits one namespace. And there are potentially cases where the concept of tenancy might not be super strict about data isolation needs. So here's an example. Imagine you are building a chatbot, a RAG chatbot that essentially acts as federated search across all of the internal tools that your company subscribes to. So you want to be able to ask a question that hits Google Docs and Notion and Slack and a bunch of other data sources that you want input. And in this case, you do want to be able to query across them, but it is handy to have some amount of tenant isolation for, not tenant isolation, but for concept of tenants for things like offboarding and batch operations. In this case, you can use a combination of nested IDs and metadata filters to help approximate the idea of tenancy in this case. So what does this look like? First, we would assign both ID prefixes and some associated metadata at upsert time. So for a given vector embedding, you might want to associate it with the SAS tool that it came from, a given doc, and then its chunk, and all of those have IDs associated with them. And then we might have a metadata blob that gives us some information about its visibility. Who should be able to see this if they ask the chatbot? Then later, when it's time to query, what we'll send up is some filter where we are doing a string match on visibility, looking for the result where something is public. Now that is the most naive possible example of what access control could look like. And we have an awesome Learn article that just came out that talks about doing proper RBAC inside Pinecone, but this is just a quick example of what it could look like to filter on metadata. Now, there's even a third way of thinking about tenancy that Kyler is going to walk you through in this example of namespace notes, where namespaces are workspaces are tenants. So I'm going to hand it over to Kyler to tell us a little bit about this app.
Thanks so much, Bear. All right, so we have reached the demo portion of our webinar. I'm going to talk a little bit about namespace notes up front. So namespace notes is a multi-tenant chat with your PDF SaaS application. It's designed to allow users to upload PDFs to various topic-specific workspaces, which in our case are the equivalent of namespaces, and then talk to them in their isolated context. So if we cut to the next slide, just to drive home the point, fictional chat with your PDF, one workspace is equal to one tenant. This should be a familiar UX to a lot of us. If we look over on the left-hand side panel, you can think of each of those different buttons as workspaces, and that's what we're going to be diving into in a second. So just to talk a little bit about what we'll cover. So I'll speak a little bit high level about the RAG methodology involved here. Spoiler alert, there isn't much depth to the RAG portion of this demo. Very simple RAG setup. We're not doing anything like re-ranking and so forth and so on. The focus of this demo is very much on namespaces and tenant data isolation. We're also going to talk about how we achieve this and how we can achieve upserting multiple documents through ID prefixing on our chunk IDs. We're also going to talk about how we add relevant metadata to the chunk data and documents that we upsert. We're going to talk a little bit, as I mentioned, about data isolation as well through namespaces and how that works in namespace notes. And finally, we're going to talk about offboarding, tenant offboarding, as Bear touched on, through data deletion. So we will jump in there in a second. So as I mentioned, and you'll see this in a minute, this is a very simple RAG setup. I went ahead and chunked and upserted a bunch of Richard Feynman lecture transcripts from his Cornell lecture series. So that's going to be our default tenant that we take a look at to start with. Otherwise, we are using OpenAI for our embedding model. And of course, we are upserting our vectors, our records to Pinecone to make the magic work. So we'll see this in a second. I just want to give a quick, very short snapshot of the project and what's going on. So we have a front end built in Next.js React Tailwind. We're using the awesome Vercel AI SDK, and we communicate with our backend, which is a Node Express server that allows us to do all of our heavy lifting and file uploading, chunking, embedding, using thread workers, and so forth. For the purposes of this demo, we're using DigitalOcean for blob storage to store some of our PDFs. And last but not least, we're using Pinecone to actually power the context that will allow us to speak with our documents. So with that, let's jump right in. So I'm going to go ahead and share my screen here. Make sure I've got the right one. Maybe just a quick confirmation that we can see my screen.
You can see your whole Chrome window with the two tabs.
Excellent. Okay. So as promised, what we have right here is namespace notes. Familiar UX, chatbot style. we have our first workspace right here, our default workspace. And as I mentioned, this is the Richard Feynman lecture series, a credit to Cornell. UX, again, UI should be very familiar. We have some prompts to get you going if you don't have a question immediately to ask. And I went ahead and added a document tray where we can see the documents that are already loaded into the workspace. So I go ahead and click on one of them, it opens up, and we can see our file, PDF file. So that's great. I am going to go ahead and ask for some quotes from the lecture series content. Get us started. So we're using the Vercel AI SDK for the chatbot functionality. As you can see, it's going ahead and it's pulling our context, pulling some random quotes for us. Or to open up one of these quotes. Again, it's showing the source document that the quote belonged to. Let's go ahead and ask it a question, another question. Does Richard speak about quantum mechanics in his lectures? Simple one to start us off. And we get our answer, yes. And in fact, it pulls a specific lecture where he speaks about quantum mechanics. So I think we get the point. We have context from the Richard Feynman lecture series here. And what I'm going to do is I'm going to create another workspace. And our goal is for that workspace to know nothing about the Richard Feynman lecture series. So to do that, I'm going to go ahead and upload a new PDF. I'm really into space travel these days, so I have 2 space PDFs. I'm going to go ahead and upload them. Let's call this space exploration. I'm going to go ahead and create a new workspace. And I have, spoiler alert, limited file upload sizes and dimensions for the purposes of this demo. So maybe a quick live debugging session. I'm using Multer to handle file uploading. And what I've gone ahead and done is I've set a limit on the file size and a max count. I'm going to go ahead and reverse this for our demo. All right. So let's try that again. Give it a second or so. And there we go. We have our context and we can see the upserted and uploaded PDFs that are there, which is great. So I'm going to ask our new document context to tell me something I might not know about space exploration. And cool, I never knew about the terrestrial planet finder before, so pretty awesome. Now for our test, I'm going to ask it, is Richard Feynman mentioned within the content? Nope, Richard Feynman is not mentioned within the provided content. And that's exactly what we want. So what just happened here? Well, to take a peek behind the curtains, we have 2 tenants now. We have one just in our default namespace, as Barrett called out earlier, we have a default. And then we have another workspace that has a new tenant ID that we created. And if I head over to the Pinecone console, we can see what's going on behind the scenes. So you'll notice here I have 22 namespaces or 22 tenants in our case. And each of these namespaces have their own context. Richard Feynman's lecture series exists in the default namespace. And if we take a look at that content, we can see all the related lecture content here. I went ahead and copied the workspace ID for those with a keen eye from our browser. And when I query for it now, I can see all the content is related to space exploration in our new tenant. So that's the concept of isolating data between tenants One other thing I'd like to touch on is the documents themselves and how exactly we go about chunking and upserting them. So if we take a look at any of these records, as Bear called out, part of what makes this work is while we have two documents in this namespace, how do we tell which document is which? Well, we took advantage of ID prefixes. So if you take a close look at the ID of this particular record, you'll notice that the first part of the ID before the colon is actually our document ID, which we generated using UID. The second part is just the chunk index, right? So as we went through and we upserted each of our records, we went ahead and constructed this ID prefix. So going back to our code, if I were to look for prefix ID, ID prefix, left a little comment for myself to come back to, we see that right at the chunking and absorption step, at the chunking step, we are creating our own prefix ID. So that's how that works behind the scenes, and it allows us to specifically target documents for certain operations. So as an example of that, I'm going to go back to namespace notes, and I'm going to delete one of these files from our context. So I'm going to go ahead and delete this one. Give that a second. And just like that, it's gone. And if I were to send a query, it will no longer have that document as a part of the context. So how do we do that exactly? Well, to target that specific document, we went about it this way. We have this function called delete document, and the first thing you want to do is list out each of your document chunks. And as we discussed before, each document has a specific prefix. So we have a document ID that we've passed over to our server, and we use that to list out all the chunks related to a specific document. Once we've done that, it's as simple as calling delete document chunks. And once we iterate over that, or we paginate and delete all those chunks, we will no longer have that document within Pinecone, and it will be outside of the provided context as well. Well, what about offboarding? What about the whole workspace? Well, as you can see, I have this delete workspace button right up top here. And this is even more simple. All that requires is specifically targeting the namespace ID associated with the workspace and deleting it outright. I'm going to go ahead and click that. And just like that, it's gone. To drive home the point, if I go back to Pinecone, we were looking at this namespace before. If I were to go ahead and hit refresh, and then try to query for that namespace again, we'll notice that we no longer have any context, as in our workspace, i.e. tenant, was deleted. So I'm going to go ahead and upsert some more records, upload a new document. I've been having a debate with some friends over the NBA playoffs. And I'm going to go ahead and upload the entire NBA rulebook to settle debate. So I'm going to go ahead and upload that. This may take a few minutes, or maybe a few seconds. So we have the entire NBA rulebook and now inside of our context. If I were to open this up, you'll notice that this is quite a sizable document. So in a couple of seconds, we have all of this context now uploaded into Pinecone, a whole bunch of information, and I could keep scrolling for days. But let's go ahead and settle some debate. So I have a very specific question. D'Angelo Russell was hit over the head while driving to the basket during one of the plays, a game this week. would that be considered a flagrant foul? I kind of think so. Let's find out. I go ahead and query our document, and just like that, if the contact committed against D'Angelo Russell while he was driving to the basket was interpreted to be unnecessary, it could be considered a flagrant foul penalty 1. In such cases, a personal foul is charged to the offender and a team foul is charged to the team. So we can see there that it does answer our question. And interestingly, if I were to open up the PDF, not only will it open up, it's opened us up to the page that describes flagrant fouls. Just zoom in here so we can see that. Okay. So similarly, once I'm finished with this, I could go ahead and upload additional documents. So say, for example, I have these 2 other documents about tips for the NBA draft. I'm not going to the NBA, but it's a good read for those who are considering it. And also some information about NIL guidelines, name, image, and likeness. So just like that, those documents are also chunked and upserted. Can open them up, see how they're different. And I can ask questions that are specific to the NBA rules now. I can also pull in context about name, image, and likeness if I'd like to, and the NBA draft tip sheet that we just saw. I'm not going to do that. I'm sort of done here, so I'm just going to go ahead and delete this workspace. And again, all of that content that was just in Pinecone is now gone. So that is a long and short of working with namespaces within Pinecone. We talked about a few things. We went through creating workspaces, chunking and upserting new documents. We saw ID prefixing. We saw how we could target specific chunks or documents for deletion. We can also delete the entire workspace or offboard an entire tenant all very easily. So with that, I am going to end off this demo and maybe we can cut back to our slides. Okay, so what you're seeing here is a little tip sheet from us with some helpful resources for RAG. As I mentioned, the demo that we just showed, very basic implementation of RAG, already effective in giving us some information about the PDFs. But if you want to go deep, learn more about how to build RAG systems for production, we'd recommend taking a look at our RAG intro document. It always comes up, so we call it out here. Chunking is always very topical, so there are many ways to do it. For folks wondering, we used a very simple paragraph chunker in our demo just now. And for a lot of use cases, that's just fine. For some use cases, you'll need a more robust method of chunking. So we outline a couple of those techniques in our chunking strategies resource in our Learn article. We also didn't really touch on advanced RAG techniques in this as well, or re-rankers. So we added additional resources for you there as well to take a look at. And then, of course, the topic of the day was multi-tenancy on Pinecone. So we'd be remiss not to mention our new article about multi-tenancy as a part of our Learn series called Vector Databases in Production for Busy Engineers. It's always busy. So we'd recommend taking a look at that. And as Bear mentioned earlier, we have a new article on RAG access control. You may have noticed that in the demo that we just showed, there was no real sort of authentication or JWT tokens being passed anywhere to make sure that access control is in place. So if that's important to you, as I'm sure it would be in production, we highly recommend taking a look at that article as well. Awesome.
All right, so I've been trying to answer Q&A questions while Kyler was presenting, but we've got lots more in the chat. So we're going to start answering those. And where is my button to stop recording? There we go.